Hi guys, welcome to our webinar on combined land plan and specifically the flock compare reports. We might wait just like another 1 minute just so that as many people can join from the call. But if you do have any questions throughout the webinar or whatever, pop them in the chat and we'll get to the questions at the end. Righto, it looks like we've got a fair few people online, so we might as well get started. As I said, welcome to our webinar on the flock compare reports for the combined land plan results. I'm joined today by Marnie and also Sophie and Victoria from the sheep genetics team, but also online we have Daniel and Sam from the AgBoo team. So today's agenda, we're going to run through 3 sort of key sections. The first bit will be a review of the enhancements that actually took place, just as a little recap. And then Marnie will run us through the actual report that's been generated. So it's a flock level report that shows you, I guess, a comparison between your results in the, I guess, current maternal or terminal evaluations compared to the combined land plan evaluation. And as I said, at the end, we'll have plenty of time for questions. So if you've got anything, make sure you pop it in the chat. So first up, we'll just go through a bit of a review of the enhancements. And the enhancements can be broken down into 3 sort of key sections. So we have changes to the data analysis pipeline, and then we have our section that we've actually combined the data sets and we've streamlined some data. And then third, we have some technical updates that have sort of resulted in better accuracy and better prediction of breeding values. So we'll go through our first bit first, so changes to the data analysis pipeline. So essentially this bit, we've moved some of the data processing from AgBoo down to the sheep genetics end. This does speed up the analysis a tiny bit, but more importantly, it means that at sheep genetics we can provide service providers and breeders with better diagnostics and better feedback for their users. That will have no impact on breeding values, not on the ranking of them and not on the actual figure that you see. We've also streamlined some, I guess, methodology across the analyses. So we had our maternal and terminal, and we're just going for, I guess, the best version of both into our combined land plan. Again, that'll have no impact on anything that you guys see. But what will have a bit of an impact is obviously the combining of the 2 data sets. So we're merging the maternal and terminal data sets, and that will obviously change the comparisons between animals and mean that you'll have new breeding values to look at, and there'll be different rankings between animals. That is going to be, I mean, that's probably the biggest update of combined land plan, but it means that we get good comparison across more breeds. It increases accuracy across a lot of traits, and we'll also then, I guess we'll get better commercial tools as a result of these changes. The second part of this is the combining of the data sets and streamlining the data, and this will have a bit more of an impact. So the first 2 points here, we are, I guess, removing some data. So the 2 bits of data that we're removing is the phenotypes that we have used from the SIL evaluation. So that's the New Zealand evaluation. And then also the phenotypes prior to 2000. So it's important to note that we're not removing pedigree information. Pedigree stays in place. We're just removing phenotypes. And this, I guess this update was looked at pretty extensively by AgBoo, and it has very little impact on current selection candidates and their breeding values. So the impact overall is pretty minimal, but it will change the actual value of the breeding value that we see. The other bits of data that we're no longer going to look at will be our hogget fat and muscle scans. Again, there's not a lot of this data coming into the evaluation, and it's not overly useful. So by removing it, we can speed up the evaluation and focus on, I guess, more useful traits. We're also going to remove single animal contemporary groups. So single animal contemporary groups are completely ineffective. Within a contemporary group, we need to be able to make comparisons, and we can't do that where there's just one animal. So we're removing that data, which essentially just speeds up the analysis. It shouldn't have impact on breeding values. And finally, we're no longer going to use syndicate sire pedigree. So you're still welcome to submit syndicate sire pedigree. It just won't be used as an actual calculation for sire pedigree. And again, there's not a lot of that data going into LAMBPLAN at the moment. Our third point here is a technical update, and this is resulting in increased prediction of breeding values and progeny performance. So there's quite a few changes that are occurring in this particular section. The first is a base change. So as I said, we're removing phenotypes from prior to 2000. So as a result of that, we have to move the base. So breeding values are presented as an animal's superiority to a base. And for most traits, that base has been set in 1990. And because we're deleting or removing those phenotypes from prior to 2000, we need to move the base. So moving the base will have a really large impact on how the breeding values actually look. It will also have a change to the rankings, but really this is probably the largest change we'll see in the actual breeding value numbers that you see. We're also going to change some of our contemporary group formations. The next 2 points on this graph are around contemporary groups. So the first is how our lifetime groups are actually built. So traditionally, so in maternal and terminal evaluations still and in merinos, we use pretty much every trait that's recorded on an animal, and that goes into the lifetime contemporary group of an animal. So what we get with that is quite a lot of splits, and then we get smaller groups with less animals in them, so I guess less effective comparisons between animals. So to try and alleviate this a little bit, we're going to focus just on wool, weck, and weight traits. So we'll only build contemporary groups from those 3 trait groups. And we've also put a few smarts in around the formation. So if an animal misses a record but reappears, it doesn't get split, and so forth. We're also changing the splicing, so the age splicing that we put into contemporary groups, and we're going to do the age splice before designating contemporary groups to stages. So this just helps us avoid some extreme ages sort of into the wrong age stages and things like that. We're also updating our fixed effect model. So fixed effects are the known non-genetic impacts on performance that we adjust for. So our birth type and rear type will be grouped into a single effect. And I think quite a cool bit of this is that we're also fitting our fixed effects directly into the model. So that essentially means that they'll be recalculated every run, and that means they stay up to date all the time. We don't need to do these recalculations again in the future. They'll stay up to date as part of the calculation in the model. We also had a look at heterosis. So when we looked at heterosis, we checked whether we needed to do it at a breed-specific sort of level, different adjustments for different breeds, but that was found not to be the case. So we've fitted a single universal heterosis, which is really exciting. We've also had a look at our genetic parameters. So parameters are, largely speaking, the heritability of traits and also the correlations between traits, and we generally review these every 5 to 10 years to make sure they still fit the population. And we've done that again because obviously we're combining 2 pretty large populations together, and we had a look at it and we've gone with a single universal genetic parameter again. So just one universal set of parameters across all animals and breeds. We've also then changed the genetic group structure. So genetic groups essentially inform breeding values where we've got gaps in pedigree. And we've revised this a little bit. So we now have 36 breed groups, and some of those are split into 10-year windows where we have quite a lot of historic data. We've refined the breed structure. So this is essentially how we model breed structure in a genomic evaluation. And we've gone for what we call a meta-founder genomic model. So essentially, this is just the genomic model that sits behind the evaluation, and it allows us to better account for ungenotyped founding animals of populations. And finally, the last one on this list is our increased weighting on the genomic relationship. So this genomic relationship is often referred to as lambda, and we would have spoken about it a fair bit at previous service provider workshops and so forth. But essentially, it's the weighting placed on the genomic matrix compared to the pedigree matrix when we talk about relationships in sheep genetics. So in maternal and terminal evaluations, our lambda value has been 0.5, so 50% comes from each source of relationship information. And we're moving that to 0.95. So that means that 95% of the relationship information on genotyped animals will come from the genomic relationship. And that particular one will have a pretty large impact on breeding values. We'll see a fair bit of re-ranking as a result of that particular change, as well as the actual value of the breeding value will change.
Thanks, Kate. So I'll be taking over now to run through some examples of flock compare reports. So this particular webinar, like we're recording it and we'll send it around to everyone that's registered after the webinar. But we're asking as service providers if you can please email Sheep Genetics with a list of flocks that you would like the compare reports for. And we can pull that out as well as some a bit more in-depth information around proportion of genotypes and number of contemporary groups and things like that, which will hopefully help you as service providers have conversations with your clients and I guess wrap your heads around changes in breeding values as much as you can. There's obviously been a lot of changes that Kate's just walked through, and some of them will be confounding, so it will be quite hard to diagnose, but we do have some tools available. So yeah, definitely get in touch with a list of flocks that you'd like this report for. We can download it and send it in a PDF version. For the purpose of this webinar, I've taken some screenshots. So there are 7 key sections of the report. The first being a pedigree summary, the second being a data summary, third is a count of contemporary groups, fourth is flock genetic trend compares. The fifth section is breeding values for the 2024 drop animals for that particular flock. The sixth section is breeding values for the size of the 2024 drop. And the seventh and final section is breeding values and accuracies at an individual sire level of the size of the 2024 drop. So there's quite a bit of information in these reports that we'll be going through, and I've just tried to pick out some example screenshots for this next section. So these are all coming from different flock reports, so they're not all from the same flock, but I've just tried to pick some examples to talk through of things that you might see, and so you can replicate and explain things to clients essentially. So we'll first focus on the top section, which is the pedigree summary. So as I mentioned, we'll be sending these reports out in a PDF, but I've just taken screenshots of some of the reports. So what we have here on the screen is a screenshot of the pedigree summary table. So we have for each of these sections, essentially certain tables or graphs of the old, if we want to call it old or current terminal/maternal analyses, and then the new, which is the combined LAMBPLAN analyses. So what we have here is a table of pedigree summary. We've got old and new columns for the number of animals with the birth type 0, birth type 1, birth type 2, birth type 3, retype 0, retype 1, retype 2, retype 3, and then the number of animals with a known sire and a known dam in both the current terminal/maternal analyses as well as the combined LAMBPLAN analyses. And then in the rows of the table, we have the year of birth being looking at the last 5 years of available data. So this particular flock report pedigree summary table only has data from 2020 to 2023 in it, but obviously if there was 2024 data, that would populate here. And then the rows are further broken down from year of birth into sex as well. So I've just taken some more screenshots just for ease of viewing. Sorry, the screenshots are a little grainy sometimes, but essentially I've just blown up the animal numbers at a year and sex level and the number of animals with a known sire and a known dam. So what this is saying is that if we focus on this bottom row here, which is the 2023 drop females, there are 593 2023 drop females in the current terminal analysis and the current combined land plan analysis that are submitted for this drop, and only 88 of those have a known sire. So that's saying that of the 593, 88 have a known sire, and then there's a significant portion of animals that do not have a known sire. And 555 of them have a known dam. And then I went through and I cross-checked against the data quality score report. So there'll be lots of, I guess, similar metrics in the data quality score report too, which will help you talk to your clients about this. And for this particular flock, there's a very large portion of syndicate pedigree only. So just being mindful that for combined land plan, we aren't using syndicate pedigree. So that's why the number of known sires is quite low. It's only 88 out of 593. So just really important to kind of think about what information is being presented in this report in the context of the enhancements that we've made for combined land plan. So next, moving on to the data summary table. This is an example screenshot of a flock's data summary table. So again, there is only 4 year drops being from 2020 to 2023, and it's broken down by males and females within each year of birth. What we have then on the column headings is the traits. So we have weight traits here from birth through to hogget weight and adult weights. Fat traits, so carcass fat, so this is post-weaning carcass fat, yearling carcass fat, and then eye muscle depth traits, and then repro traits here. So it's just a summary of all of the data that this particular flock submitted to Sheep Genetics. And then we have this broken down into the old analysis, or the current terminal/maternal, and the new combined land plan analysis. So what we have here is just a summary of data points that are being used in the analysis. So looking at where my cursor is right here, this is showing that there are 293 birth weights for females born in 2020 in this cell here. So if we go through and highlight, there are some, I guess, differences between the number of, the number of data points that are being used in the old and the new analysis, and these might be due to certain reasons. In this instance, it was due to age stage reallocation and then removal of single animal contemporary groups. So just remembering to think about why the differences might be in relation to the enhancements that we've made. And then if we have a look at the 2023 drop for the weaning weights, post-weaning weights and yearling weights, this was, there are deviations or differences, in the number of animals with weaning weight and post-weaning weight data due to age stage reallocation. So Kate mentioned before that we now look at calculating the age of that individual animal and then filtering it accordingly. So that's why some of these counts of animals have moved between the old and the new analysis. So just looking here, there was 182 that had a weaning weight in the old analysis. Now there's 116, but there's a lot more animals that have a post-weaning data point, a post-weaning weight for combined land plan. And then you'll notice that if we have a look at the reproduction section, so this far right section here, it's blank in the new analysis where there was 53 records, and this is because we don't have reproduction data for combined land plan just yet. So again, just thinking about the context as to what information is displaying in the table. So for some flocks as well, there'll be fleece information in this data summary table, as well as visuals and things like that. So just remembering that for combined land plan, we only have growth, carcass and eating quality traits currently. So this example screenshot here, I just wanted to highlight because we have, sorry, it is a bit grainy, so it is a bit hard to see, but if we focus on the 2024 drop row, which is this bottom two rows here, so females on the top of this bottom and then males on the absolute bottom, what we have is quite a substantial difference, an increase in the number of animals that have a birth weight in the 2024 drop males for combined land plan. So that's 1,350 animals in combined land plan that have a birth weight, and only 1,142 animals in the current terminal/maternal analysis that have a birth weight. So what's happened here for this particular flock is that they're site coded. So this flock has a flock in the terminal analysis and a flock in the maternal analysis that are site coded together. So once we've pushed together their data set actually increased quite substantially for combined land plan. So just trying to think of a few different instances why there might be changes in the numbers that are showing in this table for certain flocks, and trying to give a bit of an explanation as to why that might be. Okay, so the third section will be the flock compare report. Of the flock compare reports is the contemporary group counts. So Kate explained that we updated contemporary group logic for combined land plan to group only on wool, weck and weight traits. So for some flocks, you will see that there will be a bit of movement or difference in the number of total contemporary groups. What we have here is an example of a particular flock. Sorry. And I have just highlighted the 2022 drop males and females and the contemporary group numbers for post-weaning weights, post-weaning fat, and post-weaning eye muscle depth. And you'll see that the number of contemporary groups, so it was 7 total contemporary groups for the 2022 drop born females for post-weaning weight. It was 7. It's now moved to 5 for post-weaning weight 1, and then post-weaning weight 2 was 5, and it's now dropped to 4. So we actually are having less contemporary groups in this particular flock in the analysis. Same for the fat. So it was 11 contemporary groups for fat, and now it's down to 8. So just remembering that any differences in contemporary groups will obviously change the number or the proportion of animals that we're comparing their performance against. So we'll obviously have a big change in the breeding values as well. And this is a screenshot from that same example that I had a few screens ago that was the site-coded flock. So their contemporary groups have changed. Just wanted to highlight that again. So you will obviously have to kind of think about these tables in the context of that particular flock and any changes that we've made for combined land plan as well. So moving on to the flock genetic trend reports. Here's an example from a flock where the genetic trends line up quite well. So while the actual value of the genetic trend, well, the value of that particular trait's trends may be like lower. So what we're looking at here is at a trait level, each graph is a trait. So the top trait is birth weights. And the blue line here is the old or current terminal and maternal analyses trend. And then this orange line here is the new or combined land plan genetic trend for this particular flock that I've pulled the report for. So we have this at a trait level. So we've got birth weights, weaning weights, post-weaning fat, carcass fat, intramuscular fat, shear force, post-weaning eye muscle depth, carcass eye muscle depth, and lean meat yield. Quite largely speaking, the genetic trends for this particular flock for current terminal, maternal, and combined land plan follow quite a similar trend. And for this particular flock, I just went through and kind of overlaid certain kind of changes or data quality metrics. So for this particular flock, there was a little bit of age stage and contemporary group reshuffling. This particular flock had quite good data quality and was well linked within the breed, and also had a low proportion of genotypes, but also had a good proportion of full pedigree that's being captured. So just kind of thinking about all of those enhancements that we've made for combined land plan and why this particular flock's genetic trends are following quite a similar pattern or a similar trend line that largely line up despite the relative value of the flock's average trend for that particular trait being different. Where if we have a look at this particular example for this flock, its genetic trends don't necessarily marry up or like align across the current terminal/maternal analysis, which is depicted in the blue line, and the combined LAMBPLAN genetic trend. So for this particular flock, I've pulled out some data quality metrics / enhancements that are relevant. This particular flock had quite low data quality, quite significantly lower than the other flock that we were looking at. It didn't actually have any contemporary group reshuffling. It had a little bit of age stage reshuffling, but also had really low proportion of full pedigree and a high proportion of genotyping. So that's really important when we're thinking about those enhancements that Kate was talking about earlier regarding the genetic the genomic model updates, including the increase on the genomic relationship matrix or genomic relationships, which is the term that Kate referred to as lambda. And in this particular flock's instance as well, it was in the terminal analysis, but it has quite direct sire links to the maternal analysis. So quite a substantially larger data set that it's now comparing and referencing against too. So while these trends don't necessarily align between the current and the current terminal/maternals and combined LAMBPLAN, it's really important to think about why they might be, not in alignment, essentially, especially comparing to the previous slide that I showed quite aligned genetic trends. So just important to overlay, I guess, the changes and the enhancements made. So moving on now to the 5th section, which is the breeding values for the 2024 drop. We have here plots, which has the same traits as the previous. So we've got birth weights, weaning weights, post-weaning weights, fat, eating quality, and muscle and carcass breeding values here. And what we have is the correlation of breeding values between the current terminal and maternal and the combined LAMBPLAN analyses. So on the y-axis, we have the breeding values from combined LAMBPLAN. And then on the x-axis for each graph, we have the breeding values for the current terminal or maternal. And then the colored dots each represent an individual animal in the 2024 drop. And the blue dots represent animals that don't have a genotype. And the orange dots represent animals that do have a genotype. So quite largely speaking, we're probably going to see a little bit of, a high proportion of spread in or re-ranking of animals where there is a genotype available for those animals. And I just overlaid some, I guess, enhancements or data quality considerations for this particular flock. It has really high data quality. It has a high linkage to the reference population. It has a moderate level of genotyping, primarily on the male side of things in its flock. There was quite minimal contemporary grouping and age stage reshuffling, and this particular flock does have good linkage across breeds as well. So quite a high data quality flock, high accuracy flock, realistically. And so while these numbers are quite unclear, but this R number here is essentially plotting the correlation between current terminal/maternal breeding values for 24 drop and the combined LAMBPLAN breeding values for the 2024 drop. So they're not quite clear, but this is saying that for birth weight, the correlation is 0.963 or 96.3% correlation for the 2024 drop animals for birth weight for this particular flock. So quite good correlations between current and combined LAMBPLAN. And this, again, particular flock has quite high data quality and really good linkages across current terminals, but also into the maternal analyses as well. So just things to consider. This particular graph comes from a flock that hasn't done any genotyping at all. So you'll see that there's no animals that have an orange dot. All animals are blue because there is no genotype for this particular, no genotypes for the 24 drop animals of this particular flock, but same concept. We have individual traits plotted. We have the new combined LAMBPLAN breeding values on the y-axis and the old, new combined LAMBPLAN on Y and old current terminal/maternal and breeding values on the x-axis as well. So the correlations here are a little clearer. So for this particular flock, it's saying that the correlation of 2024 drop animals for birth weight is 80.2%. So still quite high correlations, a little bit more of a spread in individual animals. And then when we overlay, I guess, the data quality and certain enhancements that would infect this particular flock, it does have reasonable data quality, this particular flock. There was no level of genotyping. It has quite low linkages to the reference population as a whole. And it is primarily linked within breed, and then there was kind of minimal age stage reshuffling and reallocation. So not quite as good data quality and not quite as well linked across breeds as the other flock as well. So moving on to the breeding values of the size of the 2024 drop. This graph is essentially the same thing. There'll just be less dots on this graph because there will be less size compared to the number of animals in the 2024 drop. So same concept, individual graphs for each trait. On the y-axis, we have the breeding values for combined LAMBPLAN. And then on the x-axis, we have the breeding values for the current terminal/maternals. We have the correlation of those two breeding values, and we can also see an individual dot represents an individual sire of the 2024 drop. So again, just overlaying some kind of high-level example data quality and enhancement summaries that are relevant to this flock. It has really high data quality, again, high linkage to the reference population. There's moderate level of genotyping, primarily on the sire side of things, minimal contemporary group and age stage reshuffling, and then good linkage across breeds as well. So for those traits, this particular flock collects on-farm weights and fat and muscle scans. So really good high correlations for those particular traits of the size of the 2024 drop. We see lower correlations for something like shear force, which is obviously a harder to measure trait. It's only measured on animals that have been killed. And also we know that we know that certain traits that are like classified as difficult to measure, like shear force and eating quality and carcass traits, had a bit more of an impact from the combined LAMBPLAN due to contemporary group reshuffling, but also due to the significant increase in the reference size when we merged obviously the maternal and terminal data sets together. So this next slide is essentially just looking at the exact same section of the report, so the breeding values of size of the 2024 drop, broken down again at a trait level basis. It's just for a different flock. I just wanted to highlight a few things. Again, quite high correlations for on-farm weight traits, being birth weights, weaning weights, post-weaning weights. Same with fat and muscle scans. And there are obviously some flocks that will kind of differ in their correlations at a trait level. So lower correlations for IMF and shear force. And this is due to the fact that this particular flock was previously quite lowly linked to the reference. And was previously primarily linked between breeds, but now because of combined LAMBPLAN, we have a significantly greater reference. That's why those particular traits in this flock have changed substantially. So moving on to the final section, which is the breeding value and accuracy of size of the 2024 drop. So what this particular section is listing is a table, and for each trait that this particular flock submits, we then have the sire ID, the breeding value in the old analyses, the breeding value in the current analysis, combined LAMBPLAN analyses, and then the accuracy of that breeding value in current terminals and maternals, and the accuracy of the breeding value in combined LAMBPLAN as well. So again, just for ease of reading, I've just enlarged certain sections, sorry. So on the left here, we have, it's all anonymized obviously, but the EBV or the breeding value for current terminal / maternal, the accuracy of that old breeding value from current terminals and maternals, and then the breeding value for combined LAMBPLAN, as well as the accuracy of that combined LAMBPLAN breeding value. So you'll be able to see at an individual sire level of size of the 2024 drop how their breeding values have changed in quite a nice, easy to read table, and then also how their accuracies have changed as well. So very largely speaking, for on-farm like weight traits, there's been, I guess, minimal, if a slight increase in accuracies from the current terminal and maternal to combined LAMBPLAN, but the quite substantial increase in accuracies of breeding values for size of the 2024 drop and just in general will be for those later in life or hard to measure traits, with IMF and shear force here shown as examples, with this particular side down the bottom row going from a 59% accuracy to a 65% accuracy in combined LAMBPLAN compared to the current terminals and maternals. And that's because of all of those enhancements that Kate walked us through earlier. So that's the report done. I'll open the floor to questions, and I haven't actually been keeping track of the chat, sorry, to see if there are questions coming in. But I'll just have a little quick squiz now. Doesn't look like there's any, but if anyone has any / wants to come off mute, feel free to jump in and ask us any questions.
I'll allow microphones to be turned on for everyone. So if you do have a question, you're welcome to unmute yourself and speak up. Right, you should all have access to your mics if you want to.
I've got a question. Do I just speak?
Yeah, thanks, Anne. Go for it.
No worries. It goes back to the first part of the presentation. I was just wondering if birth type and rear type are now considered a single effect. How important is it to still record and report both of those traits?
I can answer that if you want, Marnie.
Sounds good. Thanks, Kate.
I'd say, Anne, that it's equally as important as it was previously. When we say that they've been, I guess, fit as a single effect, we're looking at birth type and rear type in combination still. It's not just one of them.
Yeah, okay, fair enough.
So, for example, if a lamb was born a twin but reared a single, that will be a 2-1. But if a lamb was born a twin and reared a twin, that will be 2-2. If that makes sense.
Yep.
Cool. But yes, definitely still need to get that information in. We'll still need birth and rear types at an individual animal level when you submit that data to Sheep Genetics. If there's any other questions, feel free to jump in.
Marnie, Sal Martin here. Just curious, in terms of the I've had some feedback re-ranking within some flocks. What's your suggestion in terms of the best way for us to get our heads around what that might be, and do you think the reports you've just presented will be adequate for us to be able to help to explain that?
So potentially, depends, I suppose, on the reason. These reports will allow a high-level summary of why that might be. It will quite depend at an individual trait level basis. Like if that particular flock has a lot of genotyping, that would be, I would say, more substantially impacting re-ranking. You kind of have to overlay, I suppose, the type of enhancement impact, whether it's a large proportion of genotyping or whether that flock had a substantial decrease in the number or reshuffling in the number of contemporary groups that they had or something along the lines of that. That can help, I guess, start diagnosing potentially why. I know I need to do a little bit more work on the combined LAMBPLAN compare tool to help make that a little bit easier for people. But But I think if you've had a look at this particular report and overlaid it with a few other data quality metrics, and you're still a bit lost, I would definitely recommend just getting in touch with us, and we can have a look at in depth in a bit more detail for certain things, for sure.
Okay, thanks. So to get hold of the reports that you've just more or less presented there as well, we just give you the flock codes, so we can't download them automatically. We need to go through you.
Correct. Yeah, they're available through, I guess, our Sheep Genetics admin access page. So it is something that we will be pulling out and sending. We're also unsure how frequently we'll be updating these reports. So if you pull this report out now and then submit a heap of data, it might be worth, I guess, overlaying any changes. So yeah, definitely get into contact with us at an individual flock level.
Okay.
We can send you a summary table of like other changes and compares at like contemporary group and proportion genotyping level and stuff, which would help given that you'll be looking at quite a lot of flocks, I can imagine.
Okay, thank you.
It's okay. So we've had a question come through in the chat as well from Emma, who's asking about shedding flocks. She says that she's got a new shedding flock that's being submitted to LAMBPLAN this year once the lambs are born, and she's wondering whether the flock will go into the combined LAMBPLAN analysis only, or whether it will go into the current terminal/maternal analyses. So Emma, to answer your question, that particular shedding flock will get submitted to us, and it will go into both essentially. So any animals that are used in the current terminal and maternal analyses automatically go through to the combined LAMBPLAN analysis. You just submit the data once to us, and then we deal with it from there.
It's also probably worth noting for everyone that all of the updates that we've talked through are occurring only in combined LAMBPLAN. The current maternal and terminal evaluations are staying exactly as they are. There's been no updates occurring in them at all.
Well, if there's no other questions, we might wrap things up. I know we're getting towards the end of the presentation, but just to, I guess, summarize, there has been a lot of changes, and a lot of those are potentially confounding. So it is quite hard to diagnose potential movement in breeding values or re-ranking. So these reports that we're providing offer, an overlay of why certain things might be happening, but there will be quite a bit of confounding in most flocks as to the movement and re-ranking of breeding values. Get in touch with Sheep Genetics, just flick us an email or give us a call with the list of flocks that you'd like to see the reports for, and we can send that out automatically. And this particular webinar will be sent out at the end of the recording will be sent out at the end of the webinar, so you can refer back to it if you're confused about a certain section or need a bit more information. But always get in touch with us if you've got any questions or wanted to kind of talk through anything specific before talking to things with your clients or explaining to things with your clients.
Awesome. There is also, hopefully most of you did jump on our last webinar on all of the changes, so you got to see them in detail, but if you didn't, they are recorded and publicly available on our website. So if you want more information on the actual updates, go and have a watch of the videos on there, but also all of the written information as well.